Algebra 2, Lesson 94. Dependent and independent variables, functions, and functional notation. Dependent and independent variables are simply whatever an equation depends on. The best example is that we use regularly are our linear equations, or our equation of the line. In our linear equation, if we're plugging values, or if we have an equation that's solved for y would be the dependent variable. The reason why it's the dependent variable is because the value of y is determined by whatever we plug in to the value of x. So like when we're graphing x using a point method, if I plug 0 into x, well then that means y is going to equal -3. So the value of y depends on what the value of x is. If the value of x changes, then the value of y changes. Now, if we were to flip this equation around and solve it for x instead of it being solved for y, then x would then become the dependent variable. Now, the reason why that matters is because the dependent variable, the independent variable is kind of what helps us determine what is or isn't a function. Now, we've got a lot of drawings here. Quite simply, hey, here we go. Here's some examples of what functions are. And functions are graphical representations of relationships. If we can graph a relationship and the relationship between two variables is functional, then it's referred to as a function. In layman's terms, what they're saying is it's a set of ordered pairs or coordinate pairs where no two pairs have the same first number and a different second number. So quite simply, if you have an x value, it cannot have two different y values. For example, if you have a group of ordered pairs, I couldn't have 2, 5 and 2, 6 because the x value of 2 has more than one answer. That doesn't work. And then if we go back to what we did on here, when we were talking about dependent and independent variables, if I pick 2 and I plug it into this equation, I'm not going to get two different values for y. I'm only going to get one. So that's essentially what they're saying, is a function follows that rule. If something doesn't follow that rule, then it doesn't count as a function. Another way to say it is that a function is something that for every value of x has exactly one answer. Now, let's talk about bubble graphs and functions. When you see bubble graphs and functions, the bubble on the left is like the x bubble, the bubble on the right is like the y bubble. Here we've got some different examples of depictions of functions, and they want to know which ones are actually functions. So we see here in A, we have two different x's, but they both have the same y answer. That is okay. We can have two different x's give the same answer for y. That counts as a function. Now, what does not count is this case where we have one x getting two different answers for y. Not okay. That's like saying if I plug 5 into an equation, I could get 3 or 4. Not true. Only one of them can be correct. If this happens, then it's not a function. Now the next one, this is not a function. And the reason why is because if I were to plug a number into an equation, I'm definitely going to get an answer. Right? I can't have a value that gets plugged in and then yields no answer. So this is not a function either. Last one, this is probably the most confusing, is they just tell you all real numbers, they give you an equation, and then there's no y values. Now what they're saying here is if I plug any real number into this equation, can I get a function? And the answer here is yes. This is an equation with a dependent variable and an independent variable, so I can definitely get a function here. Now, the most frustrating examples are the ones where they just give you pairs, because this is a little bit harder for some people. So let's say I've got set A, which gives me the pair 4, 3, 5, -2, 7, 3, 6, 3, and then I have set B, which gives me 5, -2, and then 4, -3, and 7, -2, then 5, 4. And then they'll ask you, tell me which set designates a function. Well, from here, what you have to look at is the first numbers. You want to look at and see if any of these first numbers repeat, right? So in this one, I see 4, 5, 7, and 6. None of the first numbers repeat, and all of them have an answer for y. So this one is a function. This checks out. It's good to go. Now, if I look at this one, I'm going to look for first numbers repeating. I've got 5, 4, 7, and 5. So I do have a first number repeating, 5. Now, what I'm going to check is if the first number repeats, they should both have the same y value, but they do not. This one has -2, this one has 4. What this is saying is if I plug 5 into an equation, sometimes I'll get -2, sometimes I'll get 4. This is not a function, so this one does not check out. Now let's talk about functional notation. I think we've talked about this in the past, but just in case we haven't, the way functional notation works is I can write something like this. Let's go to green. I could say that h of x is equal to 4x minus 3. Now this is read as, this is seen as the function of h. The function of h is 4x minus 3. And I can also do a different function. I can use whatever letter I want. I could say p of x. And I can say p of x is equal to x squared minus 3x. Now these are two different functions. Now what your book will do is on your problems, they'll give you two different functions. They'll say if h of x equals 4x minus 3 and p of x equals x squared minus 3x, they want you to find p of -3. Now what this means is you go to the p function, right? So first they want you to understand the notation of p. P means I'm going to the p function, not the h function, so that's pretty simple. And then -3 means I'm going to take the value of -3 and replace every value of x with -3. So p -3 would look like this. So same function, but everywhere there was an x, I replaced it with the number -3. If I can solve this, then I can find p -3. So it's just kind of like the plug-in method. So -3 squared is 9, and then minus -9. It's going to become plus positive. So p of -3 is positive 18, and that would be my answer. Yep, that's functional notation. That's how you solve, that's how you solve functions. You just plug values in, you get outputs out. And yeah, that's all we got for this lesson. If you got any questions, let me know on Moodle, and I will see you in class.